All right, welcome to The Explainer. Today we're putting on our detective hats and diving into a forensic breakdown of a classic GCSE mathematics problem. We are going to take a really close look at the November 2023 Higher Tier Paper 2, and specifically, we're dissecting question 3. We're going to look at exactly what it takes to build the perfect, undisputed answer to a compound interest problem, right down to the precise mathematical checkpoints required for success. So grab your calculator and let's get right into a problem-solving mindset.
Right, so here's the exact problem statement pulled directly from the exam paper. Andrew invests £4,500 in a savings account for 2 years. The account pays compound interest at a rate of 3.4% per year. Calculate how much Andrew has in this savings account at the end of the 2 years. Take a second to just process those numbers. Identifying the core variables is always step one in literally any compound interest problem. We've got our starting principal amount, that's £4,500. We've got our time frame, which is exactly 2 years, and we've got our percentage rate, sitting there at 3.4% per year. Honestly, it sounds pretty straightforward, right? But presenting your workings clearly and accurately, well, that is where the real magic happens.
Okay, let's dive into this. The absolute best part about tackling this specific question is that you don't even have to memorize the formula out of thin air. This is the official compound interest formula, and it's actually provided to you right on the higher tier formula sheet that comes enclosed with the exam. Total accrued equals P times 1 plus R over 100, all to the power of N. To break that down for Andrew's situation, P, the principal amount, is his initial £4,500. R, our interest rate, is 3.4. And N, the number of compounding periods, well, that's 2, since the account pays interest per year for exactly 2 years. Having this formula sitting right in front of you means you can immediately start plugging in those values.
Now, we have to talk about the points. Question 3 is worth exactly 2 marks, and it's really important to note that these are strictly categorized. You have an M1 mark, which is a method mark, and an A1 mark, which is an accuracy mark. To get full credit here, you absolutely need to show the correct method and the final correct calculation. You can't just magically write down the right answer from your calculator without showing how you actually got there. And conversely, a brilliant method with a sloppy final calculation, that's only going to get you exactly halfway. You really have to capture both.
To earn that first M1 method mark, the literal rulebook, the official mark scheme, requires a full method for 1 year or for a full method for 2 years. This is great because it actually gives you 2 distinct, perfectly valid mathematical paths to demonstrate your workings. You can either step through the problem chronologically, so calculating year 1 and then applying year 2 to that new total. Or you can use the power of exponents to calculate the whole 2-year period in just one elegant equation.
And this brilliantly illustrates exactly what we're talking about. Let's break down what the 1-year method requires on paper. To find the amount after 1 year, you take the initial £4,500 and multiply it by 1.034. Now, why 1.034? Well, because you're keeping 100% of your original money, plus adding that 3.4% interest. So 103.4% as a decimal multiplier is 1.034. Doing this calculation gives you £4,653. And guess what? That single line of working securely locks in your M1 mark. Alternatively, look at the 2-year method at the bottom there. You take the £4,500, multiply it by the 1.034 multiplier, but you raise it to the power of 2 to represent those 2 years. Writing down 4,500 times 1.034 squared also instantly secures that method mark.
Interestingly, examiners are actually actively looking for specific mathematical checkpoints in your work. So even if your written formula is a bit, messy, if the examiner sees the value 4806 or the value 9306 written literally anywhere in your working, the M1 method mark is implied. You might be wondering, where on earth do those numbers come from? Well, 4806 is the result if you mistakenly calculate simple interest instead of compound, basically adding exactly 2 lots of 153 to the principal. And 9306? That's what you get if you correctly calculate the first year's total of 4653, but then simply double it. While neither of these leads to the correct final compound interest answer, seeing these exact numbers assures the examiner that a valid, relevant mathematical process took place, ensuring you still pick up that vital first mark.
So let's see how all this builds to our ultimate goal, the final answer. If you correctly plug either of our proper compound methods into your calculator, whether you take your year 1 total of 4,653 and multiply it by 1.034 again, or if you just type in 4,500 times 1.034 squared, your calculator is going to spit out this exact number, 4811.20. Writing this down officially secures your A1 accuracy mark. Notice the formatting here, guys.
We are dealing with British pounds, so including that zero at the end to show exactly 20 cents is standard, precise practice for writing out currency.
But let's just say, hypothetically, it didn't write exactly 4811.20. Are you totally doomed? No way. The acceptable answers list explicitly allows for a few variations, which is a huge relief. They'll obviously accept the perfect standard format of 4811.20. But they will also accept 4811.2, completely dropping that trailing zero. They'll even accept 4811.202, which shows you didn't round off the final tiny decimal generated by the pure math, or even 4811.21. Knowing exactly what variations are accepted gives you immense confidence for sure. It shows exactly where the official boundaries for success lie for this specific calculation.
So, as we wrap up this forensic breakdown, I really want to leave you with this final, vital question. Does your working leave absolutely no doubt for the examiner? As we've seen today, you don't need to write a novel to get full marks. You really just need clear, unambiguous communication of your method, like writing out that precise decimal multiplier, followed by a highly accurate final number. If you can cultivate this habit of leaving a crystal clear trail of mathematical breadcrumbs, you are going to be maximizing your marks on every single paper you tackle. Thanks so much for joining me on this explainer, and keep that focused, analytical mindset sharp.